Okay, so today I wanted to talk to you about mocking and stubbing, and it's one of my favorite unit testing tools. And I've made a library that I want to show you a little bit about, a little show and tell here about how to make mocking and stubbing easier on the Salesforce platform. I don't, if you've got experience using mocking and stubbing as unit testing, can you chime in? Is there a way to raise your hands or to maybe say something in chat? Give me a feel where people are with the knowledge of mocking and stubbing.
We've got a small enough group here today that you can unmute and say if you'd like to.
Great. And if nobody volunteers, I will call on people. And I'll massacre the names. I'm terrible at pronouncing names. Anybody want to volunteer?
I'll go ahead and volunteer for you, Kevin. I have done some.
You have done some.
Yes, in jest.
Do you feel good about it? Do you feel like it's an easy thing, frustrating thing?
It can be frustrating. Getting your head around how to do it is, I think, the toughest part.
Yep.
And then once you've gotten the head around how the actual doing it, it's not terrible.
Yeah. Anybody else want to volunteer?
You want us to say that if we did or did not do it?
Yeah.
No, I never did that.
Never done it? Never done it? Okay. So let's talk about anybody else want to volunteer? I didn't want to cut people off.
Yeah, I have. Hi, Kevin.
Hi.
I have done it in my previous job. I'm Pranoti, and I've done it in my previous job, but that was not Salesforce related. So I have written some stubs in C programming.
Oh, okay. Old school.
Yeah. So right now I'm transitioning to Salesforce, and I have done unit testing a lot in my previous job. So just want to know how it's done in Salesforce. So
yeah.
Thanks.
So let's start off with a little bit of a primer here. What the hell is stubbing? So when we talk about mocks, we're talking about because you'll often hear the term mocking and stubbing used in the same sentence. So we're going to cover both here a little bit, but we're going to focus on stubbing. So mocks are legitimate objects that bypass your written methods to return a known result. And this is sort of a sleight of hand thing. If you've ever seen that magic trick where you go by and you grab a coin from behind somebody's ear and you're doing a little thing here, it's sort of that sort of sleight of hand magic. And what happens is you're going to create a mock, and that mock is going to exist as a valid object and a valid method. But instead of the written logic that you have, it's going to return a known result, right? So you can have a method that says, add these two methods together, and you can totally add these two numbers together, and you can totally bypass the inputs and the outputs and always return 0 with a mocked method. Okay. Stub objects are a little bit different. They're objects that are they're masquerading to be a known object type, but their methods are overwritten to create mocks. Okay, so a mock is generally a method, right? And a stub is generally, I realize I just have legitimate objects. This is a method. This is a method. Let me fix that there. Stub objects are objects that pretend to be a real thing, but their methods are overwritten. So there's mocked methods that are part of stubbed objects. And fundamentally, stubbing and mocking relies on dependency injection to work. And that dependency injection is the mechanism of sleight of hand. So when we talk about doing this, we're going to be working with dependency injected objects that we have created stubs of. And we'll see a little bit more of that here as we go. And I promise it's not all slides. I'm not a big fan of slides. So how these work visually is you're going to write your code that you're testing, and it's going to use an object that is either passed in via dependency injection, or it can be overridden. And I point that out because if you have an object in your class, and maybe you're constructing it in your class at runtime, you can still dependency inject your stub in there by allowing that object to be to make it test visible and test writable, so that you can go through and replace the instance that you've constructed with your mock instance. So you have to be able to get that that stub object into your tested class in order to use this. Your test class is going to pass that mock or that stubbed object in, and then when your test executes, the tested code is going to call on that object, but instead of actually executing the written method as it's defined somewhere else in your code base, it's just going to immediately return a known result. Okay, and there's a lot of things you can do with this, but may not be entirely intuitive on the first go. So let's look at an example in some code. Now, the rest of the code, there's code in an actual editor here, but we're doing this to minimize the number of times I go back and forth between Keynote and code. So we've got a class here called dateFormatter, and our dateFormatter has one method, this getFormattedDate. Okay, now it's really basic. It's going to take and call on the helper method, where the helper object we're passing in, to get today's date. So what does that helper object look like? It looks just like this down here in the corner. We've got to get today's date. It's going to return a string. We're going to return date today format. Now, if we look at this code, something should be immediately obvious. That date helper is always going to return today's current date, which could be problematic in our tests if we need to know a given date to always come back for our test case to execute and test a branch of logic. And so what happens is we're going to create a stub of the date helper method, date helper class, and a mock of the get today's date method, so that when we test this here, we're actually using a stubbed version of this date helper object, so that we always get back our given date. Now, that was probably a mouthful. I want to pause there and ask for questions, comments, and snide remarks, because I realize that this can be fairly dense, and even I trip over the distinction between mock and stub as I talk about it, and I don't want people to be like completely lost here before we dive any deeper. So, questions, comments, snide remarks?
So Kevin, this is Kalyan.
Mhm.
But does that mean that mock is more static and stub is a little dynamic? Like you can tweak and change it to however you want it to be reacting?
Yes, within reason. And by
Okay.
reason, I mean there are some system limitations. We'll get to those here in a little bit. But the big one that you have to remember is that you can set your stub. You can only create your. Let me back up. You can only pass your stub in once. So while you can create multiple stubs and use them in the same thing, you can't overwrite your definition of a stub once you've created it. But your stubs are dynamic. They're sort of a factory for creating mock methods, which is awkward language as well. But the whole mocking and stubbing thing is actually ridiculously hard to talk about. It's a sort of a computer science version of who's on first. And I hope that as we go through this, you can see how these examples that I've picked out are make it clear what's going on.
Okay.
But in our example that we're going to be using for the first part of this talk, we've got a date helper class, and this is the thing we're going to stub. And when we create the stubbed class of date helper, we're going to mock the get today's date method. And later, when we test this, we're going to be using we're going to pass in our helper object here, this helper, and that's going to be our stub, and we're going to be able to call on our mocked method here.
Okay.
I'm waving my mouse around to highlight different things, and I hope you can see that. I hope it's coming
We
through.
can.
I can see that.
Okay. Great. So go ahead.
One more question, Kevin, might be. Is that for mocking and stubbing? Is that a thing that a choice that I can should I use a mock or a stub, or I have to use either a mock or a stub?
Yes and no. So way back when, in like 2012, 13, Patrick, you may know the exact date, but somewhere back in there, Salesforce released the HTTP callout mock interface, and that is probably badly named in my opinion. It should be a HTTP callout stub, because you're actually stubbing the response and the methods there within. You can't necessarily use a mock outside of that HTTP callout mock without using a stub as well. Mocks are part of stubs. Does that make sense?
May not be clearly, but when we go forward, I'll understand better.
Okay.
Yeah.
Would a Venn diagram help?
I'll ask that. Might be if I don't understand by the time we go forward, maybe you can. Yeah, whenever we can. Thank you.
I'm just going to do it. This is why I present in edit mode. And there you go. All mocks are part of stubs, but stubs are not part of mocks.
Okay.
Okay. So here we have a mock util, and this is just a thing that helps us generate our mocks. And you see that we've got a get instance that is going to return a new instance of our mock provider. We haven't gotten to the mock provider yet, but we'll get to it. And we've got this method here called create mock. It's going to take a type that we're going to, this is the type of object we want to mock, and then it's going to give us an instance of that mock. This is sort of glue that makes everything work together. And we're not going to focus a lot of time on it because where we get into the real meat of things is this class here, this mock provider. Now, Salesforce has exposed in Apex the system.stubprovider interface. And when you implement that interface, you have this one method to handle, and it's this handle method call. And this is what allows you to specify a method and its parameters and its return types and what do you want it to return to override the functionality of your written method in this test. So we've got a handle method call, and you'll see that it's got a stubbed object. This is what you want to stub. So in our case, it'll be the date helper. We've got a string of the method name that is stubbed, and that they're using the word stubbed here. These are going to be, I'm going to use the phrase mocked. So mocked object is our date helper. Our mocked method name is get today's date. Our return type is what that method is going to return. So if you've got multiple instances of a method named the same thing, you can specify which one you're mocking here by responding to the return type. You can also differentiate based on the list of parameters and the list of parameter names and the list of arguments. So this seems somewhat redundant here, but what that's giving you the ability to do is to look at the parameter types that are being requested, and that's a list, so it's in order. It's a list of parameter names, so is this the same parameter name that is coming in, and the list of arguments. The arguments are the actual values coming in. And that allows you to be very specific about which of many very similarly signatured methods you're mocking. And you can do all sorts of inspection on that. So you can look at the return type, .getName. We've got it set so that this one returns a string. It's always going to return 8/18/2016. Otherwise, return null. Okay. Now we could go in and change this and say if the parameter type is X, Y, and Z, and the values are A, B, and C, expected values, then we want it to return 3/19/2022. This is a super powerful method, but it can be very verbose and hard to use because, as you imagine, if you take this as Salesforce has given it to you, you're having to write these system stub providers for every class that you want to stub, which I think is inefficient. So we'll get to something better here in a little bit. Now, when we go to actually run our unit test with our stub, what we're going to do is we're going to run our test get formatted date, which is the code we're actually running to test, and we're going to get a mock date helper with our mock util create mock for the date helper class. We're going to cast that to the concrete type of the thing that we're mocking. So in this case, a date helper. This is what I mean by we get a legitimate object of date helper with mocked methods. And now we're going to instantiate our new date formatter. Oh, that was not what I wanted to do. Date formatter, and we're going to run our code, dateformatter.getFormattedDate. We're going to pass in our mock date helper. Now, since our mock date helper is hard-coded to always return 8/18/2016 or 8/8/2016, we know that this unit test will pass. That's sort of the mechanics of how the system stub provider works at a really low level for Salesforce. Questions, comments, Snyder marks on that one? Going once, going twice, swinging for the fence. All right. So this can often look like a lot more trouble than it's worth. However, by stubbing your objects, it allows you to isolate your code that you're testing from external sources and external services, and allows you to truly unit test your code. Now, this is the high-level overview of why you want to do this. It's hard to imagine going to this work if you don't have specific use cases in mind. And the date formatter one is kind of you can see it as an example, but it doesn't necessarily make sense because I don't know anybody who would go to that much work to format a date. You may in your code need to do something like that, but for most purposes, the date formatter is a arbitrary and illustrative piece of code, but not really one that is useful. So we're going to look at some different examples here. And I want to show you how to make this easier. I built this SuperStub library, and it is using a fluent or a builder pattern in order to make making stubs and mocking methods much easier and fluent with one set of classes for anything in your org, rather than having to write these stub providers for everything in your org. And the way it works is something like this. So we're going to create a new stub object builder. Mess that up again. And we're going to pass in what class we want to mock, in this case foo. We're going to mock a method name called some method name with a list of parameters. With parameter types, we don't have anything for this particular one. And we're going to return or throw an exception, or throw an exception with a particular exception object, which is really helpful in testing. And then we're going to mock a second method call. We're going to pass in its return types or parameter types, and we're going to have it return something or throw an exception or throw a specific exception. And then finally, we're going to create that stub. So when we get done with this interface, when we get done calling this what is effectively a single line of code, what we end up with is foo stub that we can pass in and directly use within our unit test. That's kind of hard to follow, so let's look at the builder pattern in a little bit more detail here. The idea is, so the builder pattern is sometimes called the fluent interface, and the fluent interface is actually not the builder pattern. The fluent interface is just the idea that you've got chainable method calls that you can put on individual lines. So if we look at this, we've got builder, our constructor, and then we can chain it to another one, and then chain it to another one, so on and so forth. That's what a fluent interface is. The builder method is, or the builder pattern is the idea that you want to declaratively describe what you're doing. So I want a builder, I want to mock, or excuse me, I want to stub foo class. I want to mock this method. I want it to return Bob. I want it to do this. And it's very descriptive and intuitive. And the idea behind using a builder interface is to make it so that anybody who picks up your code and has the vaguest notion of what a builder interface is can sit down and read exactly what you're doing without having to know exactly how it happens. And I'm a huge fan of them. I think they make coding intuitive and easy. Now, you notice I put some stars there. You can have builder patterns that are incredibly difficult and unintuitive to use, and it all goes down to who wrote the builder pattern and named those methods. So if you want to adopt this, pay a lot of thought to what you're naming things, because that can be a trip up. If it's not, if your method names don't describe what you're doing, then it's not going to help you at all. And the key to the builder pattern is that all of the building methods return a builder object. And because of that, you can chain them in any order. Okay. Questions on the builder pattern?
No, I'm like not question, but a comment that I have used it and I love it. So
Yeah.
yeah.
If you've ever done anything with Swift UI or Flutter or it's really popular in UI frameworks. Not really in LWC because JavaScript hasn't really adopted that pattern so much. But I'm a huge fan. I use it a lot in the libraries I create. And so let's look at what happens here in pseudocode. This is a Rosetta Stone slide. I'm a big fan of these. So what I have on the top is some pseudocode. It's going to describe what we're doing, and then I'm going to show you exactly how to do that in live code using the SuperStub or using the stub method here. So first thing we want to do is create a new builder object, and to do that, we're going to do new stub object builder date helper class. Super simple, right? And then we're going to say we want to set an internal property. In this case, it's the method name we want to mock on our date helper. So we're going to mock get today's date. We're going to pass in some parameters. These parameters can be anything or nothing because, as it turns out, our parameter types for this method are nothing. We don't have any parameters for this method. And then I'm going to hard code this to return 3/19/2022. And finally, I'm going to create the stub. So by the time I get done with this line of code, I should really have put a semicolon after create stub. But when I get done with this line of code, we will actually have something that I can pass into a tested method as a stubbed object. Now, when my tested method uses this date stub, it's going to always return for get today's date. That method will always return 3/19/2022. Questions, comments on this? Okay. Oh,
Yeah,
here's somebody.
I have a question.
Please.
So, how does the framework determine based on the parameter passed? Because it could be an S object or something.
Mhm.
So,
We'll get to that here in just a minute.
thank-
Okay. So the question I always get then is, oh, that's cool. When should I use stubs? All the time. Anytime your tested code requires interaction with code outside your tested class. That's my general rule. Now, what people don't realize is the vast scope of what that general rule covers. So if your code requires writing something to the database and you don't actually care that it's written to the database, then you should mock that DML call. Okay. Why? Because you don't actually have to write to the database. Your unit test will run faster, and you can always have it return exactly what you're expecting, whether that's a DML exception or a list of database.insert results, etc. Now, to do that, you're going to have to sort of wrap your DML statements, and we can get into that if people have questions here. The other thing that I want to point out here is that every single time you need a method to return a specific value for the code you are testing, you should mock it. You should stub the object and mock that method. And this is because if the implementation of that method changes, your unit test will break, and it's not really a unit test. You want to know that the code that you're testing works as it should, knowing that all of the external stuff that's going on works correctly. Now, what you don't want to do is be unit testing something and find out that something else doesn't work correctly because it's changed. So you should definitely stub those objects and mock the results, mock the methods. So there are some times when on the Salesforce platform where you have to use a mock, have to use a stub and a mock. I'm a big fan of using custom metadata to allow admins to dynamically change the way code functions. Examples of this are being turn on or off triggers, to do things like build translation objects, so to go from like one API result to an S object and let them do the mapping there. All that kind of stuff I like to put in custom metadata so that the admins can go in and change it without having to deploy code. Unfortunately, you can't insert data in a unit test for your custom metadata. You can create the custom metadata record objects, but you can't insert them. So if your code relies on you being able to query them out of the database, those custom metadata records, you're going to have to stub a class dedicated to grabbing that data. And we're going to look at building an example of that. And another great example is whenever code interacts with your service layer. So if you've got a service layer pattern going on in your org, whenever you're testing something that's going to interact with another bit of the service layer, mock that. You're going to stub the object, you're going to mock the method, and you're going to move on with life, because what you're testing in this test is that your current code works as intended, regardless of whether or not the service layer works. And somebody can go change that service layer, and then it could break your test, and you don't want that. Okay, there are lots of examples of this. My favorite one was calculating tax code stuff, and the service layer would go out and calculate the tax code for I think the customer I was working with was in it's where Belgrade is. I'm trying to think of the name of the country. Anyway, they have this tax law, and you pay taxes up to a certain percent there, and then after you get a certain mark, you get a discount, and it's on your sales percentages. So this company was selling lumber. They would sell lumber, and if you bought, let's say, $100 of it, you paid 12% tax. And if you bought $150 of it, you only paid 12% on 100 and then 5% on the 50. And that sort of tax calculation can be difficult. They had a whole service layer built out for it. And when the tax code changed, they went in there and they changed their tax code settings. And then every unit test related to anything in their code, tax and sales and opportunity related, broke because all of the service layer stuff was returning the wrong numbers. That's when you should mock it. So isolate your unit test code from the service layer stuff. All right, so favorite quote from a movie. Thought we'd jump into some code here and demonstrate how this works. What I'm going to do is I've got the SuperStub code base pulled up here. Let's start with this first. Can everyone read my screen okay?
Yes.
Yes.
Yeah, we can read. Don't understand. Yeah, but we can read.
Fair enough. We're working on that. There's a couple of unique things about this code base that I want to point out to you. Everything that you would actually be interested in deploying to your org is already marked as, let's scroll up all the way, is test, which means there's not unit tests for the actual library. So what I've done is, outside of the packageable force app main, etc., I've got this directory here called tests. And in the test directory, I have some example code that we're going to go through. And I have some example tests of that code showing how you can build something to be mocked, build something consuming that mock it, and test it. Okay. So what we're going to do is we're going to go through some of those examples. And hopefully this will become super clear as to what's going on. So the first thing I have is the stub example. This is a very simple class. You'll notice there's not anything really interesting going on here. There is a method for concatenation of strings, a method for adding 4 numbers, get accounts. These are all, there's very little logic here. This is a method, this is an example of something that we want to stub. Okay, we're going to stub the stub example class, and we're going to use that in the stub example consumer class. And this is a class that requires a stub example class be passed in. This is our classic dependency injection. Now you'll notice I have a private method here, a private variable here that is the stub. What I could do is I could also mark this like that, and in my unit test, I could pass in, I could override this if I wanted to. But for right now, we're going to ignore that part. This is our classic dependency injection. We're going to require an example of our stub example class to construct the stub example consumer. I don't understand why this is so hard to pronounce all the time, but stub example consumer becomes a mouthful really quickly. So what we're going to do is we're going to have some methods here. Get is true. We're going to have one called get greeting. And you'll see that these are all returning nothing but the stubs implementation or result of get is true. So this is important here. What we're going to do is I'm going to split these side by side. And you'll look here. We've got a public Boolean is true. So this get is true is going to return false, which seems a little weird, but bear with me here. And then we've got a greeting. We're going to return the greeting, in this case, hello, so on and so forth. All of these just mirror, all our stub consumer is doing is mirroring the stubbed objects so that we can start to play around with and look at what happens when we construct our stub and our mocks, how these are overridden from the original. Does everyone follow with that so far? I'm going to pause here till somebody ventures yes or no.
So just that stub example consumer is stubbing stub example, right?
It will.
Okay.
It will.
When you pass the stub kind of stuff, right?
Yes. So we're going to look at stub example consumer tests. And the stub example consumer test is going to test the stub example consumer, but it's going to override with stubs the use of the internal stub method, the internal stub object. So let's look at what that looks like here. I'm going to make this a little bit wider. So we've got test stub builder with two methods mocked. Okay, and here we have an implement, a stub that we're creating with the SuperStub builder. We're going to create a stub example class stub. Wow, this is getting hard to talk about. I should have named these better. Let me try this again. We're going to create a stub of the stub example class. We're then going to mock the method getIsTrue. Now, getIsTrue is right here. It's going to return the implementation of getIsTrue, or return the stub that we pass in, its version of getIsTrue. Because we want to override that, what we're going to do is we're going to say, oh, we don't have any parameters for this. That's important. And we're going to automatically say return true. So if we look at our example class, our stub example, let me open the right window here, stub example class, you'll see that this is false by default. And what we want to do is we want to stub this so that the implementation of that method always returns true, regardless of what it actually is in the class. This becomes important here. And then we've also got this, we're going to mock the method called getGreeting. We don't have any parameters for that. And we always want it to return the string foo_bar_baz. When we get done with that, we're going to define our stub. That definition of stub just does the work of creating the stub object so we can use it in our test. Now, when we get to this point, example stub, or xstub, is now a stub object, but we need to call the test create stub method in order to have it create that an injectable object. So we're going to create the stub, and we're going to look here, and we're going to see this Boolean is true. We're going to do this, and let me back up here. So we're going to start our test, and we're going to create an instance of the stub example consumer, this one here. We're going to pass in our stub example that we're going to pass in our stub of stub example. Naming things is hard. If anybody has suggestions or even disambiguation notes on naming these, please let me know. But this is what we're passing in. We're passing in xstub, example stub. And when we do that, we can then run methods on our consumer object, the ones that we're testing. We're testing this consumer, remember. So we're going to call getIsTrue. And getIsTrue calls the stub version of getIsTrue. And we've defined the stub version of getIsTrue to always be true. So getIsTrue should be true. Okay? And so we'll have an assert down here that says we expect isTrue to be true, even though the default for the class is false. We're going to do the same thing with testing our greeting. We're going to call the getGreeting method. That's this method here. And it's going to return the stub that we passed in. We dependency injected this version of the stub. And it's going to call that getGreeting method. And we've overridden that greeting method to show that it's going to return foobar baz. So here's our foobar baz, our greeting. We're going to say these two things should be the same. And oh look, I have a spelling error. And that's our basic unit test. So in these unit tests, what we're doing is we're creating our stubbed object, and we're telling that stub object that we're mocking two method calls, get is true and get greeting. And when we take those method calls and execute those methods in our test, those in our test case, in this case, the test is going to execute those methods for us. We're expecting those overridden results to return back. Does that make sense so far?
Yes.
Okay, great. Now, we can do a lot of stuff with this. I'm going to let you look through the unit tests on your own. But what I've done is I want to give you a real life, non-invented reason for doing this. And what we're going to do is I've created a custom metadata type called my metadata type. I think is what I called it. So let's look at that. We're going to look at objects. I have this my metadata. Okay, and there's no fields on it, so we're only dealing with the label and developer name, that sort of thing. But we want to have some code that relies on that. So what we're going to do is we're going to create a class, and I'm going to call this one metadata query provider.
Is this the example, Kevin, you are going through, like when we have create metadata and in the test to create the metadata?
Exactly.
Okay.
Okay. So we're going to have a metadata query provider, and we'll put it in the regular directory. And oh, yes, fine. I have mine set to be very picky about names. So let me fix this that I don't have the capitalized M. Okay. So we've got a metadata query provider, and this method is going to have a public list s object. This is a fun trick. Query method, query metadata. And we can do all sorts of, we can make this as intelligent or whatever as we want. But for what I want to do right now, for what I want to demonstrate with this, we're going to pass in a query, just a simple string query. Okay, and what we're going to do is we're going to do database. We'll do list s object results is equal to database dot query. Okay, so there's nothing spectacular here, but what we're doing is we're wrapping our query of the metadata in a method that we can then turn around and mock. Okay, so this is going to it's not going to be terribly useful to us outside of querying the metadata. And I'm gonna save this here real quick. It's going to give me an error about not returning. Return that and let it save. Row. Well, yes. It's the error I mentioned. There we go. Okay. Bring that down. So we've got a metadata query provider. Now let's create a class that is going to use that metadata query provider. So we're going to do, we're going to create a class called metadata execution. We're going to call it metadata execution decision. Yeah, there we go. It's fine. Misspelling. Spelling's hard. All right. So our metadata execution decision is going to require, it's going to have a private metadata query provider called query provider. And we're going to set this to new metadata query provider, like this. Now, what we're doing here is we're setting up a property in our class that is going to be constructed automatically when we construct our class. So we can just write our code as if we always have a metadata query provider here. But we want to be able to test this, and we're going to mock it. And to do that, what we're going to do is we're going to say test visible. So even though that this is a private property that is constructed at runtime, we're going to have the ability to override this query provider with our stubbed query provider. Okay, so now we're going to create a method, and we're going to say public Boolean did fetch records, and we're going to say this, and what we're going to do is you're going to say query, we're going to say query provider dot query metadata, and here we're going to put in select name, name, developer name from, I should probably make this pretty, from, and we'll do, in this case, I called it my metadata MDT, like that. Okay, so we've got it. We're using our query provider, and then we're going to say we're going to return query. We're going to return this. I should probably assign this list as object results is equal to return results dot size is greater than 0. Right. So if we've got records, this method should give us true. Right now, if we go into our unit testing situation and we know we don't have any records, then that will automatically return false. So let's create a unit test for this. So we're going to create a class we're going to call metadata decision execution decision test. And okay, so we're going to do at is test, and we'll do private, and we'll tag this as a test. At is test. I hate that. There we go. And then we'll do static void test did fetch records, no mock, no stub. I'm waiting for the parity band to do the Salesforce parity band to do a version of no diggity, but no stub. And we'll do this, and we're going to say our metadata execution decision MED is equal to new metadata execution decision, and we're going to say test.start test med.did fetch records. I don't think we need, did I have a parameter of that? Fetch records is no parameters. Good. Did fetch records, and we're going to say system.assert expected to find no records. Now, importantly, I have no records in the database for this. And then we'll test.stop test. That's start test. Stop test. And that has to be a method call. So does this one. Okay. Metadata execution decision is not an invalid type. Did I misspell something? I probably misspelled something.
Decision, you put the S there.
Yeah. There we go. Turns out I can't spell decision to save my life. It's not you eagle-eyed observer.
It's very difficult to do live coding.
All right, so this unit test should pass just fine because our query, we're not modifying this in any way. our query is not going to return anything because we don't have any metadata records. Now, this is useful for testing for a number of reasons, but the biggest one being you can't guarantee that a metadata record is ever going to exist, even though you have the metadata defined. So what we're going to do is we're going to run this, and knowing my luck, it's gonna fail. Let's see why. Let's see. Let's make this a little bit bigger. No such column name. That's right. On our metadata query decision here, it's label. Run this test again. Still failed to run. It's probably because, oh, our assertion failed. Okay, so our assertion's failing. Let's expect it to find no records.
Yeah, that's a S set, right? So it would be like true, right? So it comes back as false, right?
Did I write it that way? Let's look at this. Return results is greater than 0, so it should return false.
Wow.
And you're right. That is the inverse of what I want. So this should be and what we'll do is we'll save this, and then what we're going to do is we're going to override this. Okay, let's do this. Run our test. Come on. There we go. So that passed because we did not find any records. But that's not a terribly useful illustration of what you can do with mocking. So let's go ahead and write a different unit test. We'll do @is_test, and we'll do static void tested fetch records with stub. Okay, and the first thing we're going to do is we're going to create a stub version of our metadata query provider. So to do that, if we look at our stub example consumer tests, I'm just going to copy this over rather than type everything. And when I go over here, I'm going to paste this in. We're going to create a stub object. We're going to call this one our query provider, and we're going to stub our metadata query provider class. So metadata query provider class. Okay. Now, everything there is fine. We've got everything working out like we want. So what we're going to do is we're going to say mocking method call. What method call are we going to mock? We're going to mock our query metadata. What did I call that? Query metadata. Okay. So we're going to query that. We're going to mock that query metadata. We're going to say with parameter types string. Why? Because our metadata query provider takes a string. Okay, not a comma. And we're going to returning. And I got to put a period there. Returning, and what we're going to do is we're going to say a variable. We're going to say mocked metadata results. Okay, now like that. Now that means we need a mocked metadata result here. So let's create a list of it's going to be S objects because that's what our method returns. Mocked metadata results is equal to a new list subject. Yeah, that'll work. And then what we can do is we can say mocked metadata, and we're going to add a S object, new my metadata MDT. We'll set the label equal to foo, and the developer name equal to bar. Okay, And so we're just going to add that to our list, and now we're going to return our mock metadata results. So whenever we call this query metadata, now we're going to get this singular result here. Okay, so that gives us the ability to mock that metadata class, and we can define the stub. And then what we're going to do is we're going to create a new instance of our consumer of that stub. We're going to do a metadata execution decision with the query provider. We're passing in that query provider so that we can use it. Now, if we look at our metadata execution decision, we don't have one. We don't have a constructor that takes that. So we can't quite do that as it's written here, as it was so helpful to try and give me. So what we're going to do is we're going to create that new one, and then what we're going to do is you say med dot query provider is equal to query provider. And this allows us to dependency inject our stub into our object. Remember, this query provider will be constructed automatically for us, but we can overwrite it because we've made it test visible. So when we do this, we'll have our query provider there, and now, and actually we want to do query provider dot, what do we call that method? Our stub consumer example tests. Let me open that again. You'll see that, open the right file. You'll see here that we did this casting and the create stub. So what we're going to do, if I remember to open the right file, is we've got this to define stub. But we're going to pass this here. We're going to say query provider, or metadata query provider, sorry. Metadata query provider, query provider dot create stub. Like that. Now, we've now overridden our query provider here, and so if we take this and we do test.start test and test. And in here, we say expected to find records. We should expect to find records because now when we call this define, let's do this. Let's put this over here so we can compare side by side. When we call define records, we should expect this query provider method to be overridden, the results to be overridden with what we are returning here, which is our mocked metadata results. So this should have a size greater than 0. So let's go ahead and we'll save this, and then we'll run the tests here. And knowing my luck, it's going to bomb spectacularly here. But while we wait for this to save and execute, do people have questions or comments about what we've done so far?
This is me again, Kevin. So
Yeah.
just this thing, does this stub actually runs the method? Like, does it cover the code, like, test class covering the code kind of stuff? Does this actually
It's going to mark coverage for this
It is.
highlighted portion.
Okay.
It is not going to mark coverage for the query provider query metadata method itself. You will have to test that one directly. Okay.
Okay. Okay.
My parameter types, it's probably a list. I think I gave my save that. I can't run the test because I can't. It didn't save. Saving. Did I just name sub-example with parameter types? Okay, so I've obviously forgotten how to use my own library. Let me look at this here. Parameter types, and got parameter types with parameter type. Yeah, there we go. It's going to not be that. It's going to be string.class. This is the actual type that we're passing in.
Okay.
And we've only got one, so we only need one.
So even if there is no method overloading there, we still have to call it give all these things, right?
Yes, and I'll go into why here in just a second. I want to show you how this functions, how you can use it, and then I'm going to show you how it's built, because the building part is the fun part with the builder class. So now we've got this saved, and I can run this test again, hopefully. Failed to run. All right, let's see why. Okay. I don't know why it's, oh, here we go. Query metadata was called on a stubbed version of, got a, okay, so the way this works, and what's happening is the builder, the reason you have to call the with parameter types is because the builder is building up a method signature that you're expecting to be called. So what SuperStub does is it not only allows you to stub things out really easily, it also does safeguards to make sure that the method was called the way you expected, so that your code, if it's generating a query, that the query you get is generated correctly, and that sort of thing. So what's happening here is we've got the parameter type here, but we don't have with parameter values, and we don't have this string listed here. So it came back and it said, SuperStub said, you called a mocked method, but nothing matches. And that's because we only had like that, get rid of this, okay? So we put in the parameter values, we save that. And what we're saying here is,
does that value actually matters now because we are forcing the returning? Like, is that like if you just put a text as a value, would that also work?
yeah, that would probably work just fine.
Okay.
But
this is
I
good.
mean, you could put anything you want in here. So, but this is what it's going to look for this to call. So this query provider, SuperStub is only going to match it if it matches directly with the name of the method that you're mocking, and its parameter type and parameter values.
I see.
So you could put anything you want here, but it's got to match over here.
But it will not return when you call the stub, right? It will not return. It doesn't matter.
Right. It doesn't matter because it'll be okay. And this one, it passed altogether. Okay. So that is how you can use SuperStub as a library to do things like inject metadata without having to write it to the database. You can do this with all sorts of things. One of my favorite things to do is I wrap all of my DML and my queries in another library I wrote called Safely, which is responsible for making sure that it does the security decisions to make sure no FSL or field level security or CRUD settings are violated in reading or writing fields. And because of that, I can stub safely, and I can always write my unit tests in such a way that they don't touch the database, or very rarely do they have to touch the database. And I have a client that I helped do this for in production, and they adopted the library and they took down their deploy testing from an hour and a half down to 5 minutes. So it can have a significant impact on the speed of things.
Can you repeat that? Did you say hour and a half to 5 minutes?
Hour and a half to 5 minutes.
Wow.
Yeah. And the thing is, I mean, if you remember any web application, the slowest part of any web application is the database. And if you're in a shared environment, a multi-tenant environment, then the database becomes even slower because you're not the only thing hitting it. And so if you can cut out the actual reading or writing from the database by mocking it, then it becomes a lot faster to run. It becomes a little bit more work to write, but it also becomes a lot faster to run. Okay, so this is how you use it. Let's look at how it's built. Okay, the first thing you do is you always use the stub builder in order to get a stub object. And so let's look at the stub class. Now, the way these are built, you've got a stub, you've got three main classes. You've got stub, method signature, and mocked method. And each one of those has its own builder built into it. It's an inner class. So here we go. We have our @isTest, because you can only use these in a test context. And we've got the stub class, and that's going to implement the stub provider for us. Now what we're going to do is we're going to have a type, and we're going to mark this as final, because we don't want you to be, messing about with the type of your stub on the fly, but we need you to be able to set it once. So the constructor requires it, and it's going to set it, and that's finally set. Okay. And then we have a list of mocked methods. Now, it's a list of mocked methods, not so much because we care about the order of the mocked methods, but because we want to be able to add and remove mocked methods declaratively in our syntax. So if we go back to this here, you'll see that we're doing mocking method call, and these three together form the method signature. And so what we're doing when we look at creating a mock is our builder will start building out method signatures and mocking the methods themselves, so that on the runtime we can match a method call with its mocked method and its method signature and return a specific value. So here we've got another one. We've got a constructor where we're going to take the object type and then some mocked methods if you want to construct that by yourself. And this is the base stub class. So if you don't like the builder pattern, you can still use the stub class without using the builder pattern. But when we get down here, I'm going to find my builder. This is an inner class for the builder, and it's going to have that object that's just going to take the object type. And what it's going to do is it's always going to return, because it's a constructor, it's always going to return that stub.builder object. Well, the rest of our methods here are always going to return our stub builders. So the deal with the actual stub builder, which is where's my mocking method call here? It's going to return. I got to find the one that actually does the work. Okay. Anyway, so what this does is you're going to always return. This is the secret of the builder pattern, is you're always going to return that new builder itself, with the exception of your defined stub. And this only exists because the builder pattern requires you to return that same builder object, or a different but modified builder object. The defined stub kicks it out of the builder pattern and gives you the stub class that you can do something with. And the stub and stub builder are not where most of the magic is. In here, you'll see that it's going to do your mocking method call and give you the ability to create those mocking methods, the mocked methods, but those are all done using the mocked method builder. So let's look at the mocked method class. And this class represents a method that you're going to mock as part of a stubbed object. So as you might imagine, methods belong to objects. So this mocked method must belong to a stub. And you're going to have the method signature, which is the third class in builder. And you're going to have some things in here like expected parameters, the return value you want, so on and so forth. And as you go to build this mocked method, you can either build up the method signature, which is what we see in the examples, or you can pass a whole one in. So if we have the ability to, if we go down to the builder, come on. And where's my builder? Here we go. So what you see here is we've got the ability to create this with the method signature builder, or the type, or the args, or we can just start doing this manually, like setting the parameter values. And we can set the parameter value with objects, with a primitive. You can set the parameter for multiple parameter values, and so on and so forth. And so there are multiple overloaded versions of this. And this particular library handles out to 4 parameters, because I'm opinionated and I don't think you should have 4 parameters per method, but that's me. But you can always modify that yourself. You can also have it return objects with IDs. So one of the things that you can do is have this return a constructed S object with a fake ID, so that when you run your code, you can test that specific IDs of objects are being returned, which is awfully handy. And the stub builder, as you go through the mocked method and go through creating this mocked method, it's going to be building out the stub builder for you. These 3 classes work all together. And so what happens is, as you execute your test and you build out your mock, what you're doing, you're saying, I want to stub this class, and this particular method on the class. In this case, I want to I want to say that it has to match the string type parameter, and it has to have this particular string in order for this mock to match. And this allows you to have multiple mocks to the same method in the same unit test, which is really powerful. And then what you can do is, as you execute this, when you get down here to define stub, that's when it's sort of going to compile all three of these things together. And these methods here are constructing not only that mocked method through the mocked method builder, but they're creating the mocked method signature. And that method signature is what we match on during the execution of the test. I'm going to pause there for questions, comments, Snyder marks. Is everyone following along? Have I lost anybody? It's okay if I lost you. This is complex and hard stuff. I don't want to tell you how long it took me to reason about this.
I need to see this again, this to sink in a little bit more.
You need to see how it's built or how to use it.
No, but I'll see it again now.
Okay.
Myself.
Okay. Any other questions, comments?
And would you please? Of course, I can look for these things. Would this be somewhere we can find also easily?
Yes.
I'll put a
This
link
is
to it in the chat for the sessions.
Okay.
let me put-
Will it be in Discord, Patrick, or?
Yes, I'll also put it in Discord, and as well as a recording to this whole session will be on Discord as well later today.
Yeah, I see that he's posted the link to the GitHub.
Cool. Thank you.
Does anybody think this is useful, or have I just wasted your time?
Oh,
It's
that's
okay if I wasted your time.
That 1.5 hours to 5 minutes, that sentence made it all. So
I mean, it's not always 5 minutes. It depends on how active the test queue is, but you get the idea.
yeah, no, if it is brings down even to half of it what it runs, because most of the time we always, like in CI/CD stuff, always
Yep.
do not do it because of the deployment problem. It
Yep.
takes so much time and all.
I mean, do we have time? I can give you an example of how that works. I forget when this is supposed to end.
I would be happy. Patrick, can you?
I'm just going to do it until he tells me to stop. I'm going to create a new class called wrapped email. Drop it in place, and I'm going to create a public database list database dot save result. I'm going to do an insert here.
While you're
as an
typing
example.
here, one of the biggest things I guess this requires is that you have these wrapped classes for things like DML operations.
Yeah.
So that is a fairly substantial change for a lot of people that would need to be either done from the start or added to and replaced to drop this into place in most orgs.
Mm-hmm. Generally, like let's say that, like in some places, we have used the DAO objects kind of stuff for doing all the database operations and all. Would this be helpful to only because that's only one place right now, right? Not scattered all over.
Yeah.
Would that be helpful if we put this on top of that also?
If I understand you correctly, yes.
Okay. All right.
Okay. Hold on a second. I'm going to show you how I do it. Well, maybe I won't show you how exactly. I'm gonna demonstrate it here. So we got a method that's going to called do insert, and we're going to have list of s objects to insert. Okay, and now what I'm going to do is I could check for security results, etc. But mostly what I'm going to do is return database dot insert to insert. Okay. Now you can't on the Salesforce platform, you can't stub or mock a system level class. So you can't do anything on database.insert itself. That's why we wrap it. Okay, but now I've got this save result here. Now I'm going to create a class called uses wrapped DML. I did not like that. What did it not like? Method does not exist. Yes, it does. That's why. So uses wrapped DML, and what I'm going to do is I'm going to create a new account. I'll say account to new account name equals foo. Okay, and then I'm going to say new. This is my opinion way of doing it. Wrapped DML dot do insert new list account. Okay, so this should do the inserting of the database, and then that's all we're going to do for this one. And that's not a constructor we want. We'll do public void demonstrate wrapped DML. Okay. Now we've got a method here that we want to test called demonstrate wrapped DML on our uses wrapped DML class. And as soon as it saves, we'll create the test class for it. Okay, and this will show us some fun other things we can do with it here. We're going to create an Apex class. We're going to do uses wrapped DML tests. That is test private. And we'll do that is test static void test test uses wrapped DML for insert. Okay. Now let's just stop here for a second and look at this. Our uses wrapped DML here is using that wrapped DML wrapper class, and because of that, we could dependency inject this. We could rewrite this to be dependency injected. So let's go ahead and do that. We're going to set a property up here, and I'm going to say private test visible private, and this is wrapped DML, and we'll call this one DML is equal to new wrapped DML. Okay. Now we don't need a constructor here, but you could also write this one to be wrapped DML, and then in your constructor say this DML is equal to DML. Either way will work. And now when we come down here, instead of doing this new wrap DML, we're going to say DML. We're going to use our wrap DML object. So we got this set up, and now in our test, what we can do is we can say, if we want to test this without wrapping it, well, this is using the wrap DML. So what we're going to do is we're going to do stub, and we're going to do wrapper, DML wrapper, DML stub is equal to new stub builder, and we're not doing stub example, we're doing the wrapped DML class. And we're going to do mocking method call do insert, and we're going to do with parameter types, and this is going to be a list of SObject class, and with parameter values is going to be new list. In this case, it's going to be
anything, right? Account.
It's yeah, and we're going to have this be name. New account name equals, what do we call that? Name foo. Foo. Like that. And then we're going to say returning nothing, because that's a void method, right? No, I'm sorry. It returns a list of database save results. Returning saved or mocked database saved results. Create stub. Okay, and like in our metadata execution test, we want to call define stub, not make stub. Define stub. Okay. We're going to have to create this mock database save results. So what we can do here is we can say list of database base dots save results. Result mocked database save results is equal to new list database dot save result. And we can do new database dot save results. We'll do that. So we've got our database save result created, and we'll pass that in. We've defined that stub. And now what we want to do is we want to test uses wrapped DML. So we'll do uses wrapped DML. Let's do our new uses wrapped DML. Now, because we either can pass in our wrapped DML or we can override it, let's do an example of passing this in here. So we're going to pass it in, and we're going to say wrapped DML, and we're going to do DML stub, and we're going to do create stub. So when we're going to pass this in as our created stub, and we're going to cast it to being our wrapped DML. And once we've done that, now we can do test.start test, and we can do uses wrapped DML dot demonstrate wrapped DML, and this is going to be a list of database dot save result, and I think that's right. No, that's void. Okay. Because our other thing is we're just going to do uses DML, we're just going to execute it as a void, and we're going to do test stop test, if I can type, and then we'll do system.assert select ID from account, and we're going to say assert equals like that. Okay, so what we're doing here is we're saying that we're going to call this uses wrapped DML, having stubbed and mocked it out, so that when we call the do insert method, we're not actually going to execute this database.insert method. We're going to return our mocked results. So our mocked results. So go ahead.
So that's what you're asserting, right? Not actually inserting it.
Yeah, it's not going to actually assert it. We're going to assert that we have 0 records in the database when this runs.
Okay.
Okay. I gotta save this first, and then we can run it. Failed to run? What? Type cannot be constructed, save result. Yeah. We're going to do this. I'm just going to let it do its thing. And we're going to return an empty list. That's fine for our testing purposes. We don't actually need it to return a specific database save result. Okay. And now when we run this, no whammies, no whammies, no whammies. It ran. Now here's the sort of acid test of this. We're going to logs. We're going to get the Apex debug logs. No debug log. Turn it on for the replay debugger so that we can pull our logs. I don't know why it's not on by default. Come on. Okay, so now when we run our test, we're going to be able to pull the logs. And what's important here is that when we pull our logs, one of the things we shouldn't see in here is rows, right? We've pulled our aggregation 0. We pulled our query. There are 0 rows returned, but most importantly, that's we don't have any DML statements being executed. Okay, so our test bypassed our wrap DML. It never called the actual insert, and yet it still, in this case, could have returned, depending on how you write it, returned a list of save results, or I have a wrapper class of this so that I can construct it as a result. Okay.
Okay. So and did you say that it will actually not cover that line, right? The actual insert line. It will
Correct.
not go there, right?
Correct.
So we are sacrificing that 1 or 2 lines coverage, but you are getting this runtime, very fast execution kind of stuff,
You're
right?
going to get very fast runtime, but what you can do is you can turn around and then you can write a traditional unit test for this class.
That one run thing, right?
That is just this one line, yeah.
And I see that there is static, like if our past parameter is kind of not static, right? So that time, like let's say that I am having something, the past parameter would not be a static. Like here, we are passing the name foo, right? So I'm having some kind of test where the parameter would change depends upon something, right? So in that case, can we still write a stub?
So the reason this passes, okay, let's back up. So what happens is when you're building the method signature that is going to be mocked, and that's a combination of the method call name, the parameters for that method call, and the parameters values for that method call, that combination creates that method signature. And you're saying that you expect this particular method, do insert, to be called with a list of S objects, and that list of S objects has to be a list of account with the name of foo. Now, the reason you know that to be true and what you want is because your actual code that you're testing uses that particular thing. Now, if this was dynamic or something like that, then what you could do is you could leave off the parameter values, and you're just saying it has to be called with a list of S objects. Does that make sense?
Okay, so now the stub will be created just expecting a parameter type, doesn't get locked it down to a parameter values only for specific thing, and now I can still use that same stuff for different test scenarios and all, right?
Yes.
Okay, cool. Thank you.
Great questions. Anybody else have other questions?
Yeah. So on line number 9, would the stub still work if we add another parameter value on the left? Yeah, we add type to the account. So does stub still work?
Like if you did
Yeah.
like here.
Yes.
What will happen here is when this runs, this signature will no longer match what is actually being called in the code. And so we'll get an error. We'll get an exception saying, look, you didn't match what you told us to look for. So if we run this test now by having added something different, we're going to get a it doesn't match. So you get a failed to run. Bottom. So I grab the lock and you see this is what we're getting. Stub exception. Do insert was called on a stub version of wrapped DML. So this is the object we've stubbed, but no mocked method matched the signature and parameter values. Known mocks include, it's going to tell you the mocked method count. It's going to tell you the name is the method signature is do insert, and the parameters that it knows to mock are a list of S objects with the account that were called the parameters that were passed in at runtime are account name equals foo, but we've told it to look for shipping city equals Bob as well, and that didn't exist. So what you can do is we take that out and just say, give me just list S object of class. Okay, and rerun this again. We get that same error because it knows that to look for the mocked method name of do insert, and it knows to look for the parameter types, but the types of this call are list S object, and the parameters of the call at runtime are account name equals foo. So the SuperStub library allows you to be, it's almost like I was sort of channeling Jest or what is the Jasmine when you write sort of behavioral tests. I expect this call to be done with these parameters. And so the parameter types and the parameter values become very important in making sure that your code is executing as you expect. And that allows you to be very flexible in how you construct your mocks. Because you're doing this, here, you could also put in here where mocking method call do insert with parameter types list S object class, and you can say
Another
with
one, right?
parameter values. Yeah, you can build this out however you'd like. And instead of saying foo, we can say bar, and now we put this here. When we save this, we've just changed what we're expecting in terms of the values, and now either one of those will work. Either one of those will be mocked. Mocking method call string. Why is it? Did I misspell something? Method does not exist. In my example, this is why I provided the example code and tests, because consumer test. Here you can say returning. You've got to have your returning there. So if you want to do this, you've got to have that returning also.
For every stub, right? You need to have that. All three things.
Yeah. So you got to well define your thing. Now that it's going to return this, and you have to do the return because that's what's going to actually return back a stub object you can continue. Otherwise, it's not finishing out the method signature. So there you go. You can just keep adding those on, and so you've mocked out every method or possible invocation style of your method to your code. And if we were to run this again, having mocked those two, we get it passing because we said bar or foo is fine. Now, if we were to also do bar foo shipping city equals Bob. And over here, we were to go in and, this is too small. Let me make this bigger. We were to do another test or do the same thing here where we came back later and said account 2 is equal to new account name equals our shipping city is equal to Bob. That, and I were to make another call, dml.toInsert, like that. When I save this, that definition is still going to be used because we're using the same DML that's been overruled, or it's been stubbed. So if we run this, oh, it's giving me an error. Let's see why. Name foo. Did I put that wrong? Shipping city equals Bob. The parameter types of this call are list us objects, and the parameter values of this call are. That's exactly what's there. Okay, well, I think I've got a typo or something going on here. You get the idea about how that can work.
Yeah. Thank you.
I
Okay.
think what Patrick was saying, to do this, I see that there is some kind of, we need to be within our boundaries of, we should know what variables, how many stuff we're using, so that we can create the stub accordingly and not a wild range stub kind of stuff.
Mm-hmm.
So some discipline needs to be there. I get it.
Yep.
But this is good. Thank you.
Yeah. All right. I'm going to say one last call for questions, comments, and remarks. Thanks for letting me present today. I really appreciate it. This has been, I told you earlier, I didn't want to tell you how long it took me to work all this out. It took me about 10 months of constantly tweaking and playing with this before I got to where I am with SuperStub in terms of, I think this builder pattern for describing these is expressive and intuitive. So, once you learn learn the library, it becomes pretty easy to do. Like, I'm mocking a method call with these parameter types and these parameter values. It becomes fairly easy to use consistently, and I've seen it being used for great effect.
Thank you. I would love to implement it and give some good saying that, hey, thanks, Kevin, helped me bring it up.
I posted a link in the chat to the other library, the one I use called Can the User. It contains a class called Safely, and Safely is the one that it's my wrapper for all DML and queries. And so that is the what I end up mocking or stubbing, so that I don't have to do database work in my unit tests.
Yeah. Thank you.
Cool.
We